I'll move on to the next thing. Now, the main idea behind, like the motivation behind doing this project from the very beginning was that I wanted this stadium to not just end up being a glamorized sculpture at the end of the like the legacy of the games were very important to me. So I wanted to put the stadium to a very good noble use even after the games were over. So I adopted the concept of biomimicry, which I have explained to the honorable jury members in the last two stages as well. I'll skip that and move over to something. Now, since this is in a desert, the entire design was focused on minimizing the incident solar radiation. I wanted to adopt a design which minimizes the heat gain so that people are very comfortable over there because the temperatures can reach up to 50 degrees Celsius. So what I did was that I provided an external envelope for the stadium. Like I first designed the entire stadium and then it is like you cover it up with a drape, an external envelope. So that envelope was designed to minimize the incident solar radiation on that. How I did that? I took aid of parametric design process for that. I made a Rhino script for that. I'll very briefly discuss that. Where like what I did was like for the starting, suppose I took a module. Like I knew that my stadium was going to be 194 meters in radius. Like this was the largest thing. So I took a polygon of 194 meters radius, and then I started playing with its numbers. Like what could be its height? Would it be 9? Like the height could vary, the segments of the polygon could vary. It could be a 4-sided, 12-sided, 5-sided. Now these are the parameters on which I evolve a form which will give me the minimum incident solar radiation. So I discussed these things, and then the number of polygons, the height, the offset of each strip. So this way, this led to the design being developed in vertical strips of 9 meters, 7 meters. Now, an optimized holistic approach was taken to determine that. So this way, one strip was made, and then another was made, and then third was made, and so on and so forth. Like I parametricized the entire thing. Now the time came for the insolation analysis. I made a script keeping in mind all the equalized solar radiation calculations regarding like the time of the year, that like the maximum temperatures are reached in June. So I designed the envelope for June for 4 p.m. that would be time the math would be played. So I put up in all these parameters into the design, and then took aid of the software to now, so when I plugged up these designs, I ran a computer program, it's called DevelopMagos. I ran it to evaluate my design, to give me something. It started to evaluate each iteration, like if it takes one strip. Yeah, so parametric building envelope evolution. So it check the building for all the various iterations possible. Like if it's a 5-sided polygon, then what would be the incident solar radiation? If it's a 6-sided polygon, of height, offset of distance. So I threw him the software 4 parameters, and based on that, it drew up the 12,000 solutions in 20 hours to evolve the design. I'll just quickly show you. Now this is a 20-hour time-lapse video of the simulations being done on my computer screen. As you can see, the profile of the like this is the sectional profile of the stadium, and this is the overall view of the stadium. This shows how the each strips height offset from the previous strip, and number of segments for that strip, for that polygon. Like these are the strips. So height of each strip, offset, like one is sometimes it's offset inside, sometimes it's offset outside. All these things to like give up a form which under these conditions would be the most ideal, most optimized for incident solar radiation. To reduce it as much as possible. So these are all the calculations being done in the fraction of a second, like it could be 20 hours, but I've just compiled it. So it is optimizing, slowly the form of the stadium is being developed by the computer. It is just telling me like you'll end up reaching a solution which will be the most optimum for you. it serves 12,000 solutions in just 20 hours time class. Now this was a profile that it threw me up, like if I take these two base and then a self-shading form for the upper 2 and 3 things. This was a profile it suggested to me to adopt to minimize the solar radiation to the base. But being a designer, it is my ultimate say what I adopt and what I do not. I do not like this thing very much. So I started optimizing it again and again, and finally I reached a solution which offered me, like it told me like you'll have 7 segments for the ground floor and 7 segmented polygon for the ground floor, 8 segmented polygon for the second floor, and based upon that it threw me up a form which reduced the energy consumption of the building by 27%. I optimized it from the last step itself, and then the final step was like from where I started to where I was after 24 hours of simulation. I got a form that was 26% more optimized than the previous one with reduced energy loads.